Hi everyone. Fossils are fascinating not only because they are the remnants of life in the geologic past. From them, we can also derive a lot of information regarding the evolution of life on Earth. For example, all the modifications and adaptations that living organisms have undergone to survive. However, they are also very useful tools to date and correlate rocks of similar ages across long distances. Let's talk today precisely about how we can use fossils to correlate rocks of the same age that may be in different locations. I hope you enjoy it, and don't forget to like, share, and subscribe. In our last video dealing with geologic time, we learned that fossils are useful in relative age dating of rocks. That means that they can be used to determine if a rock is older or younger with respect to another one in a particular location. But how do we date and correlate rocks that are separated by large distances? How do we know that they have similar age? To date and correlate rocks, we can use fossils of similar ages by using a fundamental principle in geology. It is called the principle of faunal succession. The principle of faunal succession was formulated by this gentleman, William Smith. It is very useful in correlation of rocks and constitutes one of the foundational principles of assessing geologic time, including what we know as the International Stratigraphic Chart. It states that in a conformable succession, fossil organisms succeed one another in a definite and determinable order, and therefore, any time period can be recognized by its fossil content. As an engineer, Smith noted that each rock formation in the canals he worked on contained fossils unlike those in the beds either above or below. Further, he noted that sedimentary strata in widely separated areas could be identified and correlated by their distinctive fossil content. Fossils document the evolution of life through time and represent an orderly arrangement of faunas that we can use to correlate. To do so, we use certain fossils called index fossils. Index fossils are called index fossils because they are relatively abundant, widespread geographically, they have a distinctive morphology. This means that they are easy to recognize and they are limited to a short span of geologic time, so their presence provides an important method of matching rocks of the same age. Of course, not every rock at all times in each location contains the index fossils. To overcome this, we use a group of fossils, or what we call a fossil assemblage. This is, we analyze not only one particular fossil, but a group of them and check their geological ranges. This means the span of time that each one of them lived. This way, we can find the age of a particular rock with a higher level of certainty and overcome the lack of other fossils.
I'm coming up a long way because it's an amazing trail, but I also want to take you to a site where we're going to see a really cool rock that you guys would love. Come with me. There are some places on Earth that open to our eyes to teach us the power of nature. And I want to enjoy this adventure with you. What we're seeing around these cliffs is millions and millions of years represented in these sediments. A sedimentary succession with different colors, different fossil content.
These clips also offer something unique to learn about the history of life on Earth. But to do so, we need to take a closer look. Fossils are so abundant in this bed, and likely we could use them to date and correlate beds of similar age in order to understand the stratigraphic succession of this particular area.
Wow, what an amazing place. We came here because I have to show you a wonderful rock. I want to show you one of the most amazing examples of the history of life on Earth. Look at this. Isn't it amazing? The whole bed is full of shells. Hundreds and hundreds of them, perhaps thousands of these shells. And It is just amazing.
Now, let's say that we move to another location, far away from where we just found these fossil shells. As we move along this coast, in that cliff over there, in that bed, we find again this bed with the same fossils. Thus, in this case, we can say that these rock layers are age equivalent. That means they have the same age as they share the same fossil content. So we can use a particular index fossil or an entire fossil assemblage in establishing the age of a particular stratum or correlating them across vast distances. Index fossils are very important in stratigraphy, and in the beginning of geology they were very useful in establishing the geologic time scale. This is not only macrofossils. In addition, microfossils are often very abundant, widespread, and quick to appear and become extinct. They constitute ideal index fossils. We can also use fossils in environmental interpretation. For example, these fossils are made of shells and are found in limestone rocks. Since limestones mostly form in marine environments, we can reasonably say that we can interpret that in this region, at the time of the formation of this rock, was covered by a shallow sea. Also, by using what we know of living organisms in the modern settings, we can conclude that fossil animals with thick shells, capable of withstanding pounding high energy waves, like the ones we are found in some modern shorelines, for example, are the ones who lived here. So fossils are not only useful in relative dating and correlation, but also in deducting information about past conditions for life on Earth. Despite common belief, fossilization is not the norm, but rather the exception. Why do we say that? Well, because when an organism perishes, its soft parts commonly quickly get rotten, dismembered, transported, decomposed by bacteria, eaten by scavengers, etc. This is particularly true in tropical environments or settings with abundant fauna or a dynamic environment. Occasionally, however, the remains are quickly buried by sediment. The sediment in this case acts as a protecting case that shelters the remains from any of the destructive processes in the surrounding environment. Thus, rapid burial favors preservation by providing a quick protecting safety area against normal decay or damaging processes operating in the environment. So this video showed us that fossils are not only the remains or traces of ancient life, but also that they can be useful in many different ways in geology, as they can be used to establish the relative age of rocks and correlate rocks of the same age. Thus, they constitute a powerful tool in stratigraphy and evolutionary studies. Thank you for watching up to this point. I hope this video contributes to increasing your admiration and amazement for our planet and the life in it throughout its history, and that is now part of the fossil record. Please let me know in the comment box, what do you think is more accurate, if we use only one single index fossil to date a particular stratum, or an entire fossil assemblage to do this? And more importantly, why? About myself, well, I do like to use an entire fossil assemblage because it gives me more option and variety, just in case any of the index fossils is missing. Please let me know in the comment box and I will do my best to answer all your comments. Don't forget to like, share, and subscribe, and I will see you in our next video. Ciao!